Okay, so last problem on the review is problem number 15. It's a little particle motion question. I'm not really sure how much we need this one. We've done a lot of these over time, but it has been quite a while since we've done. So we'll go ahead and take a look at it. Maybe this will be helpful. So we got this particle moving along the x-axis so that its acceleration is given by this formula right now. Now, I suppose this is probably worth going through because we haven't done a lot of them going backwards. So we want to find the velocity. So we want to remember that the velocity is really just the integral of the acceleration with respect to time. So in doing this, so I also know the velocity at 1 is 168, right? So there's a couple of ways that we could do that. One of those ways would be to take the antiderivative and get 6t squared minus 78t plus some constant c, right? And that would be the velocity at some time t. But they did give me the fact that the velocity at 1 second was 168. So I could put 168 out here, and I could plug in the number 1 for each of the t's, and I could find out what c happens to be, which is not too bad. So let's see, I'm going to take my 168, subtract 6 from both sides, and add 78 to both sides, and it looks like I got c is 240. So that's not a bad way to do it. And so we found that v of t at any value of time is 6t squared minus 78t plus 240. Now, that's not a bad way to do it, but we also did say that we could say the velocity at some time t would be 168 plus the integral from 1 to time. I guess we should say t of 12x minus 78 dx. Now, again, that's going to feel a little bit awkward when we do it this way, but remember, at this value, that's what we had, and I'm wanting to find that number from 1 to something else. And so the antiderivative of 12x would be 6x squared, right? Minus 78x, and that's going to be evaluated from 1 to t. So I'd have 168 plus, I'd get 6t squared minus 78t, but then I need to subtract what I get if I plug in 1. And if I subtract 6 and I do that, you're going to notice that we get exactly the same equation that we got before. It's all of the same elements that we saw when we plug it in. And we would end up with v of t equals all of this stuff. You get 6t squared, you get minus 78t, and you're going to get a plus 240. So these are two different ways to view that problem. I actually personally kind of like the first one, but there's a good reason to think about it that way because sometimes it helps. Now, in the second problem, it says, when is this particular particle going to be at rest? And that will be at rest when 6t squared minus 78t plus 240, or in other words, the velocity is 0. Now, this should not be a big shocker that all of these numbers were rigged to be divisible by 6. I believe that's a 13 and a 40. And that is a nice factorable quadratic. Two numbers whose product is 40 that add to 13 were 5 and 8. And so the time when that would be at rest or have a velocity of 0 would happen at t equals 5 and t equals 8 seconds. Now, the interesting thing about that is that means at 5 and 8, it's at rest. This is the velocity function because it's a parabola, right? So it was going forward, going backwards, going forward, positive velocities and negative velocity. Now it says, let's find the displacement over the first 8 seconds. Now, the displacement is literally just the integral from 0 to 8 of v of t dt. Now, again, I don't actually need to know the initial position. It's actually not something that I'm necessarily going to need to do that. But the displacement from 0 till 8 is going to have some forward motion and some backward motion in there. So if we took our antiderivative of 6t squared, we're going to get 2t cubed. I guess that's 39t squared plus 240 t. We're going to evaluate that from 0 to 8. And of course, plugging in 0 is not going to do much. So we're just going to have 2 times 8 to the third minus 39 times 8 to the second plus 240 times, oh shoot, 2 times 8 to the third minus 39 times 8 to the second plus 240 times 8. And all of that gave me the number 448 units. I don't think we have any units in this problem, so it'd be units, meaning it went forward 448 units. So whatever this number was bigger than that one that canceled it out by that. Now, of course, if we wanted to find the total distance traveled in the first 8 seconds, what's going to happen is I would really want to integrate from 0 to 5 of v of t dt. And I'm going to subtract the integral from 5 to 8 of v of t dt because this portion is positive and this portion is negative. So we have the same integral that we had before. And we're going to evaluate that from 0 to 5. And then we're going to have the same integral that we had right here. But we're going to do that from 5 to 8, and I'm going to do that as a subtraction. Now, really quick, I'm going to go ahead and do that on a calculator off to the side because I want to save a little bit of time. So I'm going to go ahead and type in my problem, which was 2t. Let's see, it was I want to make sure I do v correctly. So it was 6t to the second, right? 6t to the second minus 78t plus 240. And I'm going to go ahead and I'm going to do a math numerical integrate from 0 to 5 of alpha, mess that up a little bit, of alpha trace y1. And again, that's going to give me that first piece. So we went forward 475. That's this portion. And then we'll go ahead and do it again, but let's find out what happens from 5 to 8. Now, this number should be negative because it's underneath the axis. So I got negative 27. So, of course, we're finding total distance traveled. So it would be 475 plus 27. And that's at 502. Now, of course, I did mention this to you guys before that we could have gotten away with this a little bit differently if we did the following. We could do that numerical integration directly from 0 to 8. And instead of just doing alpha trace, I'm going to go ahead and put an absolute value of that alpha trace y1. And that's going to force all of those values that were negative, that portion of the graph underneath, to pop up. And we should get exactly that same number of 502, a little bit more efficient. Now, the last thing it asks is let's find that equation of that population for any time t. And that's the last one. So, of course, we're going to find that integral, the s of t is the integral of v of t dt. And that's going to give me t cubed minus 13t. Oh, careful, careful, careful. That was my antiderivative. I already did it up here, was 2t cubed minus 39t squared plus 240t plus some constant that we don't know yet. But in the big picture up top, it said s of 0 was 5. So clearly, if I plugged in 0 for all of these and my answer is 5, then that means my position at any time t is going to require my c value to be 5. And so we are now done. And like I mentioned, we could have said, we know that the position at 0 is 5. So let me fix that here. The position at 0 is 5. And we could have done this kind of story. But like I said, I think this is a little bit easier just to put the C there and let it run because you get the same exact story. Hey, hopefully that was helpful, and I will see you guys back in class later. Bye-bye.